Preparing for a Python developer at Kyndryl interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What are the main differences between lists, tuples, sets, and dictionaries in Python? Lists are ordered and mutable, so I use them for collections that change. Tuples are ordered but immutable, making them useful for fixed records or dictionary keys. Sets store unique values and provide efficient membership checks. Dictionaries map keys to values and are ideal for structured lookups. In a Kyndryl automation script, I might use a list of servers, a set of processed host names, and a dictionary containing each server's status and metadata. While answering, compare ordering, mutability, uniqueness, lookup complexity, syntax, typical use cases, and how your choice affects maintainability in enterprise automation or data processing scripts. Question 2. Explain Python's mutable default argument problem and how you prevent it. Default arguments are evaluated once when the function is defined, not each time it runs. Therefore, defadd x items equals reuses the same list across calls, creating hidden state. I prevent this with defadd x items equals none, then initialize items to inside the function. This pattern is especially important in reusable Kyndryl tooling, where one request's data must never leak into another request or job execution. Make sure to cover function definition evaluation, shared state across calls, a concrete list example, the none sentinel pattern, and when immutable defaults or explicit factories provide safer alternatives. Question 3. How does Python manage memory, and what causes memory leaks? Python primarily uses reference counting and supplements it with cyclic garbage collection. An object is normally released when its reference count reaches 0, but cycles require the garbage collector. Apparent leaks often come from global collections, unbounded caches, callbacks, or references retained by long-lived workers. I investigate with tracemalloc and memory profiling, then bound caches, release resources, and avoid retaining large objects unnecessarily. Garbage collection is not a substitute for ownership discipline. In your answer, discuss reference counting, cyclic garbage collection, object lifetimes, lingering references, generators, caches, profiling tools, and practical cleanup strategies for long-running services. Question 4. When would you use a generator instead of returning a list? I use a generator when results are large, produced incrementally, or may not all be needed. A generator yields one item at a time, so it avoids building an entire list in memory. For example, I can stream matching lines from a multi-gigabyte log and process them immediately. The trade-off is that generators are usually consumed once and do not support random indexing. For repeated access, I would materialize the results deliberately. Be sure to mention lazy evaluation, memory efficiency, one-time iteration, pipeline composition, performance trade-offs, generator expressions, and examples involving large logs, inventories, or streamed API responses. Question 5. Explain decorators and give an example relevant to production Python services. A decorator wraps a function to add behavior without changing its core implementation. I commonly use decorators for timing, logging, authorization, or retry policies. The wrapper should accept args and kwargs, and I use functools wraps so the original name and documentation remain available. For example, a retry decorator can catch transient API failures with bounded exponential backoff. I keep decorators focused because hidden control flow can otherwise make debugging difficult. In your answer, cover higher-order functions, wrapper behavior, functools, wraps, preserving arguments and metadata, cross-cutting concerns, and suitable uses such as logging, retries, authorization, or timing. Question 6. What is the difference between shallow copy and deep copy in Python? A shallow copy creates a new outer container but keeps references to nested objects. A deep copy recursively copies nested objects as well. Therefore, modifying a nested list in a shallow copy can change the original structure. I use copy copy when shared nested data is intentional or irrelevant, and copy. Deep copy when isolation is required. However, deep copying can be expensive and may mishandle external resources, so I prefer explicit reconstruction for complex configuration objects. Make sure to explain nested object references, copy versus copy, deep copy, immutable values, performance implications, and how accidental shared state can affect configuration or request data. Question 7. How would you handle exceptions in a Python application that integrates with enterprise APIs? I catch the narrowest expected exceptions and classify failures as transient or permanent. Network timeouts and rate limits may justify bounded retries with exponential backoff, while authentication or validation errors need correction instead. I set explicit timeouts, preserve exception context with chaining, and log structured details without secrets. For retried operations, I design idempotency carefully so duplicate requests cannot create duplicate resources. Unexpected exceptions should reach centralized monitoring with a useful correlation identifier. While answering, discuss specific exception handling, validation, retries, timeouts, idempotency, structured logging, safe user messages, exception chaining, and distinguishing transient failures from permanent errors. Question 8. What is the difference between multiprocessing, threading, and asyncio in Python? Threads are useful for I/O-bound work because waiting releases execution time, but Python's GIL limits parallel CPU-bound execution within one process. Multiprocessing uses separate interpreters and can run CPU-heavy tasks in parallel, at the cost of memory and communication overhead. Asyncio uses cooperative coroutines and is efficient for many concurrent network operations, provided libraries are non-blocking. I choose based on workload, operational complexity, and whether shared state must be minimized. Be sure to compare CPU-bound and I/O-bound workloads, the GIL, process overhead, cooperative scheduling, blocking calls, shared state, and examples from infrastructure monitoring or parallel automation. Question 9. How would you design a reliable Python script to automate server health checks? I would separate configuration, connection logic, health rules, and reporting into testable modules. Each check would use timeouts, least privilege credentials, bounded retries, and structured results rather than printing directly. I would run independent checks concurrently when appropriate, but cap concurrency to protect target systems. Partial failures should be reported without hiding successful checks. Metrics, correlation IDs, and secure secret retrieval make the automation supportable in production. In your answer, cover configuration management, connection timeouts, parallelism, authentication, retries, structured results, observability, secure secrets, testability, and safe handling of partial failures. Question 10. How do you test Python code effectively in a production engineering environment? I use unit tests for business rules, integration tests for databases or external services, and contract tests for API expectations. With PyTest, fixtures provide repeatable setup, while mocks isolate boundaries rather than replacing every internal function. I test success paths, validation errors, timeouts, retries, and partial failures. Coverage helps identify gaps but does not prove correctness. In C, I combine formatting, static analysis, tests, and security scanning before deployment. Make sure to cover unit, integration, and contract tests, PyTest fixtures, mocking boundaries, dependency injection, edge cases, coverage limitations, deterministic tests, and C quality gates. Question 11. What are context managers and why are they valuable in Python? A context manager guarantees setup and cleanup around a block, even when an exception occurs. The with statement invokes enter and exit, while context_lib Context Manager offers a simpler generator-based implementation. I use context managers for files, database transactions, locks, and temporary resources. For example, with open path, as file automatically closes the file. This makes ownership explicit and prevents resource leaks, which is critical in long-running automation services. In your answer, explain deterministic setup and cleanup, the with statement, enter and exit, context lib, exception safety, and examples involving files, locks, database connections, or temporary resources. Question 12. How would you improve the performance of a slow Python program? I first reproduce the slowdown and measure it with profiling tools such as cprofile, pyspy, or line-level timing. I check algorithmic complexity, repeated database calls, unnecessary serialization, and inefficient loops before considering micro-optimizations. Typical improvements include indexing queries, batching I/O, using sets for membership, caching stable results, or adding concurrency for independent network calls. I then benchmark realistic workloads and verify that latency, memory usage, and correctness all remain acceptable. While answering, mention measurement before optimization, profiling, algorithmic complexity, database calls, I/O batching, caching, efficient data structures, concurrency choices, and validating improvements with representative workloads. Question 13. What are Python type hints, and how would you use them on a team? Type hints document intended interfaces and let tools detect many mistakes before runtime. I annotate function parameters, return values, collections, and important domain models, using modern union syntax where supported. Tools such as mypy or pywrite enforce consistency in C, while type hints also improve IDE navigation. They do not validate external input automatically, so API payloads still need runtime validation. I adopt typing incrementally, prioritizing public interfaces and complex workflows. Be sure to discuss readability, static checking, function contracts, generics, optional or union types, gradual adoption, mypy or pywrite, and why runtime validation may still be necessary. Question 14. How do you secure secrets and sensitive information in Python applications? I never hard-code credentials or commit them to source control. Applications should retrieve secrets from an approved secret manager or injected runtime configuration, with least privilege access and regular rotation. I use TLS, avoid logging tokens or sensitive payloads, and redact exception details where necessary. Separate development, test, and production credentials are essential. I also scan repositories and dependencies for exposure. Security includes limiting what the process can access, not only hiding the password. In your answer, cover secret managers, environment separation, least privilege, redacted logs, encryption in transit, rotation, avoiding source control, dependency security, and preventing accidental exposure through exceptions. Question 15. How would you build a resilient REST API client in Python? I would wrap a reusable HTTP session with explicit connect and read timeouts, authentication, request correlation, and consistent error handling. The client should understand pagination, rate limit responses, and retry-only safe or idempotent operations using bounded exponential backoff. Responses need schema validation before business logic consumes them. I would expose domain-focused methods rather than leaking HTTP details throughout the application. Metrics for latency, failures, and retry counts make production behavior visible. Make sure to cover session reuse, authentication, timeouts, status handling, pagination, rate limits, retries, backoff, idempotency, schema validation, observability, and clean separation from business logic. Question 16. Explain object-oriented programming in Python and when composition is preferable to inheritance. Python supports encapsulation by convention, inheritance, polymorphism, and abstract interfaces. I prefer composition when behavior can be assembled from independent collaborators, because it reduces coupling and makes testing easier. For example, a monitoring service can receive a client, rule engine, and notifier rather than inherit from a large base class. Inheritance is appropriate when there is a genuine substitutable relationship and shared behavior is stable. The goal is maintainable change, not maximum abstraction. In your answer, discuss encapsulation, inheritance, polymorphism, abstract interfaces, composition, dependency injection, substitutability, and how design choices affect testing and evolution of enterprise systems. Question 17. What is the purpose of virtual environments and dependency management in Python? Virtual environments isolate project dependencies so one application cannot silently break another. I define dependencies explicitly, pin or lock versions for reproducible builds, and separate development tools from runtime packages. C should install from the same declared configuration used for deployment, then run tests and vulnerability scans. I also review transitive dependencies and update them deliberately. Tools such as venv, Poetry, or pip tools can support this workflow, depending on team standards. While answering, cover isolation, reproducibility, pinned versions, dependency conflicts, lock files, packaging, vulnerability scanning, see consistency, and differences between development and production dependencies. Question 18. How would you process a very large log file without exhausting memory? I would iterate over the file line by line instead of calling read or read lines, which loads everything into memory. A generator can parse, filter, and emit matching records incrementally, while bounded batches support database writes or aggregation. I would handle encoding errors deliberately and use gzip-compatible streaming for compressed logs. If processing exceeds one machine's capacity, I would partition the data or use an observability platform rather than forcing Python to hold the entire dataset. Be sure to mention streaming iteration, generators, incremental parsing, filtering early, bounded batching, encoding errors, compressed files, backpressure, and when external tools or distributed processing are more appropriate. Question 19. How do you make Python automation idempotent and safe to rerun? An idempotent automation run produces the same desired state whether executed once or repeatedly. I use stable resource identifiers, check current state before changing anything, and update only when necessary. For destructive operations, I add dry run support, explicit confirmation, safeguards, and audit logging. Transactions or distributed locks may be needed when concurrent runs are possible. Idempotency is especially valuable in scheduled infrastructure workflows because retries should recover safely after partial failures. In your answer, discuss desired state, existence checks, stable identifiers, transactional updates, dry run mode, locking, retries, audit logs, and avoiding destructive actions without explicit confirmation. Question 20. Describe a Python project you would propose for improving IT operations at Kyndryl. I would propose a service that correlates monitoring alerts with configuration and ticket data, then recommends or safely triggers approved remediation actions. Python would handle API integrations, rule evaluation, and asynchronous job execution. I would begin with stakeholder interviews and a narrow, measurable use case, then add authentication, approval workflows, idempotency, audit trails, and observability. Deployment would include automated tests and rollback. Success could be measured through reduced mean time to resolution and fewer repeat incidents. Make sure to cover business impact, requirements discovery, API integration, secure architecture, observability, testing, deployment, rollback, stakeholder communication, and measurable outcomes such as reduced incidents or resolution time. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.